Hello, it's Mrs. Ringrose, and we are continuing our work on right triangles and Pythagorean theorem. So next up is I need you to be able to appropriately use the converse of the Pythagorean theorem. So remember, the converse is when you switch the hypotenuse, not hypotenuse, haha, it's a right triangle joke. When you switch the hypothesis and the conclusion. So if the Pythagorean theorem says that when you have a right triangle, a squared plus b squared equals c squared, then we can flip that and we can say that when a squared plus b squared equals c squared, then you have a right triangle. So when is it used? When you want to prove a triangle is a right triangle. And we can actually also use it to show when a triangle is acute or obtuse, which we will also go over soon. So this is a classic example right here for you, and we're going to state if triangle ABC is a right triangle or not. So again, we have to correctly identify that this is the hypotenuse, and this one is a leg. And we're going to put those together into the Pythagorean theorem and basically see if it works. So, does 9 squared plus 15 squared equal 3 radical 34 squared? Well, 9 squared is 81, and 15 squared is 225. And the way this works is you do 3 squared and times 34, because the square root and the square on 34 basically cancel each other out. They're inverse operations. So I have 306, right? Sound good? And then we got 9 times 34, which is also 306. So, since both those two sides are equal to each other, we can conclude that this is a right triangle. So, yes. All right, again, so the converse says that if we can show that a squared plus b squared equals c squared, then our conclusion is that it's a right triangle. All right, so let's try it again with the next one. So basically, is triangle RHS a right triangle? So we don't know which one. I mean, the other one too, I kind of guessed. So it would seem, if this was a right triangle, that this would be the hypotenuse because it's the largest side. That's another reason why I would pick it. And the largest side has to be opposite the right angle. So let's try 22 squared plus 14 squared and see if that gives us 26 squared. Okay. So 22 squared is going to come out to 484. 14 squared is 196. And 26 squared is 676. And I add these two together and I get 680, which does not equal 676. So the conclusion is that triangle RHS is not a right triangle. All right, so that's pretty much going to be most of what you're going to see. You're going to use the Pythagorean theorem converse to show that triangles are not a right triangle. Sounds good? And then the extension of that, remember I said earlier that you can also show that it's, you can also show a triangle is an acute triangle and an obtuse triangle based on if the largest side is less than the sum of the squares or if it's greater than the sum of the squares. So I know that's a lot to take in right there. So basically, if I have a situation where I take the longest side and I set it up like this, so again, if a squared plus b squared doesn't equal c squared, right, it's not a right triangle, but if a squared plus b squared is bigger than c squared, then it's acute. All right, that's what that means. And we're going to practice this in class a lot, so hopefully it'll make a lot more sense. And then also, if we take an obtuse triangle and say the largest side is C, actually that part should not be squared. Then if you get a squared plus b squared is less than the longest side squared, then you can conclude that the triangle is obtuse. So we can actually prove now when triangles are right, obtuse, or acute using the extension of the Pythagorean theorem's converse. So exciting. So sometimes you're going to get questions like this, right? So can segments with these lengths make a triangle? All right, so this is, and then what kind of triangle is it? So basically, we need to find out if, remember the triangle inequalities? So is that going to be greater than that? And then also, so basically I'm just checking the triangle inequality theorem to make sure this is in fact a possible triangle. So 4.3 plus 6.1, is that greater than 5.2? All right, so, and you could do the math probably in your head. They all check out. This one's going to be a number that's greater than 7, and that's greater than 6.1. The second one, it's going to be greater than 11, that's greater than 4.3. And then the final one, that's, over 10, and that's greater than 5. So yes, this is a triangle. And then secondly, does this make a obtuse triangle, a right triangle, or an acute triangle? So the largest side is going to be my C. That's the only thing that really matters. So I'm going to make A equals 4.3, B equals 5.2, and C equals 6.1. And I'm going to use the Pythagorean theorem and find out what comes out of that. Because we don't actually know if it's equal, if it's greater than, if it's less than. We have no idea. So it's like a big mystery. All right, so 4.3 squared is 18.49. And 5.2 squared gives us 27.04. And 6.1 squared gives us 37.21. And if I add these together, I get 45 and 53/100ths, which is larger than c squared. So when c squared is less than the sum, or when the sum is greater than c squared, we can conclude that this makes an acute triangle. Okay, so when c squared is bigger, it makes an obtuse triangle, and when c squared is smaller, it makes an acute triangle. I don't know how many times